Hello and welcome to the second video of Scan DRC series. I'm Ankit Trivedi from Technology Enablement Team at Siemens EDA. In this series, we will explore various Scan DRC rule check and understand their roles in ensuring robust scan design implementation. We will start by looking at T3 DRC rule check, understand why it occurs and how we can systematically debug and resolve it. Now let's understand what exactly T3 DRC means. The shift procedure must create a sensitizable path from the scan chain output back to the scan chain input. An improperly sensitized gate in the scan path causes an error condition which the tool represents as a T3 DRC violation. When is T3 reported? T3 is reported when the tool is going from setup to analysis mode while scan chain tracing from scan output to scan input. The significance of T3 is the scan chain continuity is broken. Some part of the scan path is not connected, blocked, or misconfigured. T3 can occur in these contexts. And one important point, T3 is always treated as an error. We can't downgrade its severity to a warning because a broken scan chain directly impacts stability. Most common cause of T3 DRC is shift clock defined incorrectly in shift procedure, missing or incorrect pin constraint, missing clock definition, tap controller in wrong state. To understand T3 DRC, let's take two cases. First case, improper tap controller state. Second case, missing functional clock. Let's start with first case. In this case, the error message shows that scan tracing fails at TDO pin. So the first step would be to analyze T3 DRC using command analyze DRC violation. If tracing stops at TDO pin, we always verify whether the tap controller has correct value during test setup so that it can reach in shift DR state in shifting procedure. For that, we run set gate report DRC test setup. And finally, we have to check TMS value in test setup because an incorrect TMS can lead to the tap not entering the shift state. We can check it by report gate TMS. So this slide shows TMS value in the test setup mode. To understand whether the tab controller reached the correct state, we simply compare these TMS value with JTAG state diagram. As we know, when TMS is 1, it goes to test logic reset state. When TMS is 0, it goes to run test idle state. When TMS is 1, it moves to select TR state and continues moving through the test depending on each TMS value. So by following the TMS sequence from test setup output, we can track exactly how tap controller is progressing through the state machine. Now, if we look at the last value of TMS in the test setup procedure, it is 0. This indicates that the controller has reached the shift DR state. From this analysis, we confirm that the controller is in the correct state. So the T3 violation is not due to an incorrect tap state at the end of test setup. The next step is to check whether the TMS pin is properly constrained. This is important because during the capture cycle, the value of TMS must be held at 0. If we don't define this pin constraint, the tap state stability during capture can't be guaranteed. And when the state stability checks fails, it reports T3 violation. For this, we check value of TMS in all state using set get report DRC state and report gate TMS. From TMS value analysis, we saw that the TMS changed to X during the capture cycle. This means tool doesn't know what value TMS is holding. So the state become unstable. To fix this, we need to add an explicit pin constraint for TMS to 0 using the command add input constraint TMS-C0. After updating this constraint, we run the flow again using set system mode analysis. Now tool checks DRC violation while transitioning from setup mode to analysis mode. After applying the TMS constraint, the tap state remains stable during capture. Now there is no T3 violation. Now let's move to case 2 of T3 DRC. In this case, the error message shows the scan tracing stop at this register and the tool immediately flag a T3 violation. To analyze this, we use command analyze DRC violation T3. This command brings up the T3 violation in the hierarchical schematic window just like you see in the figure. Now, when we observe the schematic, we see the clock is going to X, but during tracing, the clock should actually pulse. While tracing, we see it is coming from clock B. This clock should pulse, but instead the tool is seeing an X value. Since the clock is undefined, tracing can't continue and therefore tool reports T3 DRC. So this is the root cause because the clock is not defined. The tool raises a T3 error. To fix this, we simply add missing clock with off state 0 using add clock 0 clock B. Once the clock is added, we run set system mode analysis. This forces the tool to recheck the design while switching from setup to analysis mode. Now, after adding the clock, when the recheck happens, we don't get any T3 DRC. So the issue has been resolved. This brings me to the end of the second video of Scan DRC series. For any queries, please contact me at the email address provided. We will continue with more Scan DRC in the upcoming video. Thank you.